Mhm, mhm. Hello, could you please confirm once that you can see me, you can hear me, as well as you can see the slides?
Yeah, your voice is clear.
Okay, okay. Thank you. So, good afternoon, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department from IIT Kharagpur, and I'll be taking your live interactive session on the course Farm Machinery. This course is taught by Professor V.K. Tiwari, Director, IIT Kharagpur. So what we'll be doing in this particular session, I'll be posting some of the questions based on the previous week's content in front of you, and you have to answer them based on your knowledge. Then in detail, I'll tell you the explanation as well as the concept lying behind the question. Okay. So the very first question for today's session is this one. As per the BIS standards 6316 to 1993, the size of the trial plot for testing tractor operated seed drill shall not be less than. Okay. And your options are zero point 0.1 hectare, zero point 0.2 hectare, zero point 0.5 hectare, and 1 hectare. Okay. These are the particular options. Okay. Please do try to answer this particular question. Okay. It's a theoretical question. If you have gone through the lectures, there sir has clearly discussed this particular code as well as the standards. Okay. Not to be that you are correct in the very first attempt, but do try to give me the correct option. Okay. Okay. Point two. Very good. Yes. Let us look at the correct option. Yes, it is definitely point 0.2 hectares. Okay. So this is the particular code. Okay. IS 6316 to 1993. Okay. I'll zoom in it for you. Okay. Here you can see Indian standard sowing equipment, seed cum, fertilizer drill. Okay. Sowing equipment, seed cum, fertilizer drill, and this particular is the test code. Okay. Here scope has been mentioned. It has been mentioned for what purpose this code is intended to. Okay. Then just a second. Okay. Yes. Here I was. Yes. See here, the scope has been mentioned and the reference has been mentioned. Okay. For what purpose this code is intended for, and the in the reference it is written specification for seed cum fertilizer drill. Okay. And this particular is the first revision, and here it has been mentioned how to design particular implement. Okay, that is in another part of the code. Okay, another code. Okay, this particular is intended for testing the seed cum fertilizer drill. Okay. So metering test, see here, calibration is written. Okay, then seed damage determination test is written. Okay, so using those procedures, you can calibrate your seed cum fertilizer drill, as well as you can determine the damage to the seeds. Okay, for field test, here field operation has been mentioned. Okay, how to do the field operation, how to do the placement, what is the power requirement, what is the field efficiency, labor requirement, ease of operation and adjustment, suitability and soundness of construction. Okay. Then how to select and prepare the seed drill for testing. See here, selection procedure has been given. Okay. How from a commercial factory. Okay, we have to pick one sample for our test. The procedure has been mentioned. Then preparation, how I will prepare my seed drill. Okay. Then see here, some laboratory metering test is there for calibration. Okay. This procedure after the class from the PPT, please do try to see it. It is a very favorite question of the semester examinations. Okay, of the course farm machinery. Okay, yes. Then fertilizers. Okay, which type of fertilizer we have to put. Okay, then how to jack it up, and then how to measure the amount of seed which is getting dropped. Okay, yes. Then you have to record the mechanical damage. Okay, to the seed. Okay, after this. Okay, how to just record the data, that is also given in your annexure C. Okay, then seed for testing the seed uniformity. See here, two particular methods are there: sticky belt method and sand bed method. Okay, I'll tell you about these in great detail. Okay, in the future questions, as well as I'll give you a brief idea about these methods here only. Okay, in case of sticky belt method, what we do just reading the things line by line and then explaining you. Mount the drill on a stand and allow a 10-meter long center to center belt to travel under the furrow openers or C tubes in such a way that the speed of the belt is equal to running speed of the drill. Okay, you have to lay down a particular sticky belt. Okay, that is given here. Okay, or a belt. Okay, mount the drill on a stand and allow a 10-meter long center to center belt to travel under the furrow openers or the seed tubes from which the seed would be falling. Okay, in such a way that the speed of the belt is equal to the running speed of the drill. Okay, in case of the drive is taken directly from the feed shaft of the seed, keep the relationship between speed of the feed shaft and belt the same. Okay, as that of the feed shaft and ground wheel. Okay, same speed on which the speed of operating of the seed belt and the speed of operation of the belt on which the seed will fall after uh, the ground wheel will run. Okay, that has to be the same. Then apply a sticky paper of grease to the belt to facilitate the proper embedding of the seeds without any displacement. Okay, then keep the fertilizer tube as close as to the belt as possible. Okay, the belt used should be painted and marked in centimeters for quick reading. Okay, operate the drill and observe the number of seeds dropped for each meter of belt length for recommended seed rate. Okay, what is the recommended seed rate that only you have to use in this particular sticky belt method. Okay, very simple. Okay, not much explanation is required. Another method is sand bed method. Okay, in the facilities for conducting tests as given in 4.2.1 does not exist. Okay, if you are not having a sticky belt and conveyor, okay, then you can use this particular method. Prepare an artificial level bed of 25 centimeter depth from fine sand and of a length at least 5 meter and width equal to nominal width of the drill. Okay, allow the drill to travel over this bed with furrow openers or C tubes lowered as near to the top surface of the bed as possible. Okay. Observe the number of seeds dropped and the average distance between two seeds for each meter of bed length. Same parameter which was there in the sticky belt method. Same parameter you have to also calculate in your sand bed method. Okay. Repeat the test at least 3 times. Okay, and for repeating the test, get the sand seed for separating this grain from the sand. Okay, yes, in this particular question your question was asked regarding the field test. Okay, so in case of field operation, it has been clearly mentioned here: operate the drill in a well prepared seed bed that is at least 15 centimeter deep, firm, fine structure, smooth and level, relatively free of surface stress, and at good moisture content. Moisture content you have to keep according to the seed germination conditions of the crop. Okay, that is what is required here. Then the size of the trial plot shall not be less than 0.1 hectares. Okay, and zero point 0.2 hectares for animal drawn and tractor operated seed drills respectively. Okay, so in this particular question, okay, see just here, it was asked as per the BIS standard, the trial plot for testing tractor operated seed drill shall not be less than zero point 0.2 hectares. That would be the correct option. Okay, clearly mentioned here, no particular if and but is there. Okay, as far as possible, the shape of the plot should be rectangular. Okay, and the ratio has also been given 2:1. Okay, follow the general procedure as for calibration, except remove the ends of the seed and fertilizer tubes from the furrow openers. Attach a bag to each end to collect the seeds and fertilizer, whichever is in the case. Okay. Also mark of the field at a distance that when traversed will represent a convenient part of the hectare, and use the same kind of seed and fertilizer that has been used in the calibration test. First, you have to perform the test under the uh, laboratory conditions, and then you have to go for a field test. Okay. Repeat this at least 3 times for maximum, minimum, and recommended feeds rate settings. Use the same identical settings as in calibration test. Okay, both of these methods as well as the setups are present at our institute, IIT Kharagpur. Okay, then we test the fertilizer and seed drills. Okay, each state agricultural university as well as the IIT Kharagpur. Okay, they have been given the authority to test the agricultural equipment. Okay, and provide the certification. Just for your kind information, so we also perform a lot of tests at our institute also. Okay, so this particular procedure that has been laid out by the BIS that we generally follow. Okay, if the uh, manufacturer wants us to test our instrument, okay, test his instrument, okay, using some another uh, test code, maybe some ASTM or any other foreign or Indian test code, then we perform the test according to that code also, along with BIS, but primarily we use BIS. Okay, yes. Then another part here, it has been written how to place regarding the placement of the seed and fertilizer drill. Okay, then calculating the power requirement. Okay, then how to mount. Okay, all these things have been mentioned here. Yes. Then assessing the ease of operation. Okay, each and everything has been written. Field efficiency, how to calculate the labor requirement. Okay, everything has been mentioned. And similarly, how you can report the results after the this particular reporting results, a particular detailed table is there. Okay, that we have to fill, as well as at the end we have to provide the authorization signatures as well as the name of the people who were involved in the testing of that particular equipment. Okay, this was regarding BIS code 6316 to 1993 1993, and the correct option was 0.2 hectares. Okay, any doubts regarding this code as well as the procedure? If any doubt is there, then please do ask me. Okay, rest I think we can move on. If no doubt is there, please do tell me.
No doubt, we
No
can
doubt,
move
we
on.
can move on. Okay, okay, we can move on. Very good. See, next question. Okay, the material of construction for furrow openers of a seed drill. Okay, here you have been asked the material of construction for furrow openers of a seed drill. Okay, is it mild steel? Is it carbon steel? Is it high carbon steel, or both mild steel and carbon steel? Okay, please be very careful regarding this particular question, because this is the basic of our machinery. Okay, very basics. Okay, I'll explain each and every steel in great detail. Please be very careful. Okay, this question is very relevant from farm machinery course point of view. Okay, as well as from design point of view. Okay, yes, do try to answer it. Okay. B. Okay. Good. Carbon steel. Okay. Carbon steel is a general term. Okay. It involves high carbon steel. Okay. Then low carbon steel, medium carbon steel, depending on the level of carbon. Okay. Yes. Okay. Good. See here, the correct option would be high carbon steel. Okay. Why? I'll tell you. First of all, let us see what are the different types of steels. Okay. Mild steel. Okay. This mild steel is a low carbon steel. Okay. Also known as low carbon steel. It typically contains carbon about 0.05% to 0.25%. Okay. And there are trace elements. Other elements are manganese, silicon, sulfur. Okay, these are also present, as well as cadmium is also there. The zirconium is also there. These particular trace elements are added to enhance particular properties. Like zirconium is there for luster. Okay, so similar to this, there are various trace elements also. But the most important component which determines the property of the steel is carbon. Okay. Mild steel, also known as low carbon steel, it is containing 0.05% to 0.25% carbon. Okay. Now, the point which has to be noted here is this particular point, that as you will increase the percentage of carbon in steel, your ductility will decrease and your hardness will increase. Okay, this particular point you have to note down. Okay, you can write it. If you are having a notebook also, you can just write it, that in this particular if you will keep this particular point in your mind, then you will never get confused between what types of steel and their particular uses. Okay. Yes. Mild steel is relatively soft and ductile as compared to higher carbon steels. Why? I already explained you the reason in my first statement. As you will increase the percentage of carbon in steel, the ductility will decrease and hardness will increase. Okay. So mild steel is having the least amount of carbon. Okay. Among the various types of steel. That is why it is known as low carbon steel. Okay. It will be highly malleable. It will be highly ductile. It will be having excellent weldability. Why? Because weldability depends on the melting point. Okay, the weld material, okay, that has to form a molten pool along with the steel. Okay, along with the metal or the steel. So when it will form a good or a lower temperature molten pool, when the uh, softness will be higher. Okay, so in case the carbon content is large, then hardness is also very large, higher. Okay. So it will not be able to form a molten pool much easily. Okay. That is why the mild steel is having excellent weldability. Okay. Then corrosion resistance. Just see here, mild steel is having poor resistance to corrosion. Okay. It often requires protective coatings such as paint or galvanization. After the galvanization process, the steel which comes out of the factory or the in the market is known as galvanized steel. Okay, GI, galvanized iron sheet, or GI sheet, or galvanized steel. Okay, this is the thing. How it is used? It is used in construction, automotive parts, structural components, and general fabrication work. Okay, just a quick question. In case of mild steel, okay, I have not told you every type of steel, but at this point of time only, I just wanted to ask one particular question. In case of the mild steel, the ductility is high. Okay. And in case of other high carbon steels, the carbon percentage would be larger. So ductility would be somewhat less, hardness would be increasing. So what do you think the shock absorbing property will be more in case of mild steel or in case of other high carbon steels? Just this quick question. Shock absorbing property. How can you just say about it? Any idea?
Shock absorbing property will be better in uh,
Mhm.
mild steel.
Very good, very good. Yes, it is absolutely correct. Shock absorbing property would be highest in case of mild steel as compared to the other high carbon steels. Okay. Why? Because here the metal is highly malleable, it is highly ductile. Okay, so it will have a greater tendency to just absorb the shock waves inside itself. It can undergo deformation, which can be temporary, which can be permanent. Okay, that is why the shock absorbing ability would be highest in case of mild steel. Okay, yes. See, carbon steel it is a general term. Okay, carbon steel encompasses broad range of steel types. Okay, primarily containing carbon as the main alloying element, can be categorized into low, medium, high carbon steel according to the basis of the carbon content. Okay, yes. Strength as the carbon content increases, the steel's hardness and strength also increases. I already told you, but its ductility decreases. Okay, malleability, lower carbon steels are more malleable, while higher carbon steels are more brittle. Okay. Lower carbon steels are having more malleability. Okay, I already explained you. High carbon steels are having more brittleness. Weldability, higher carbon content reduces the weldability. First reason I told you the molten pool. Another reason is when the molten pool would be formed. It would be formed at a higher temperature. Another point is when the molten pool will be formed, the carbon in form of slag, okay, it will float to the top. Okay, it will further enhance the temperature at which the molten pool would be formed. Okay, so carbon interference is there in the molten pool. Okay, that is another reason why the weldability decreases. Okay, you must be thinking that 0.5%, 0.25%, okay, and 0.75%. These are very less percentages. But when you will go at very micro level, okay, then in the bonding with the iron, okay, these when the welding is done and when you will chip off the slag, then you will realize that how much carbon is there. Okay, okay, it looks very less, but it is very large. It means percentage is very less. Okay, but when actually it comes out from the steel, then it is very large. Okay, the quantity in form of ash, okay, or the slag, that would be slightly large. Okay, in case of higher carbon steels, that you can practically see also. I particularly have seen, that is why I am telling you this particular experience. Okay, yes. Then generally carbon steels have low corrosion resistance and may require protective measures. Yes, this is particular point of view. Okay, they require galvanization, coating with zinc. Okay, yes. Then wide variety, in every case, okay, you must be uh, in a room, okay, in any environment, you will be finding lot of steel, a lot of metal, a lot of iron around you. Okay, almirahs, from automotive parts, from everything, steel is a very important component, okay, in our economy also. Yes. Then high carbon steel. Okay. Low carbon steel, I told you, also known as mild steel. Okay. High carbon steel, it is having steel percentage between 0.6 percentage to 1%. Okay. Then trace amounts of other elements would be there: manganese, zirconium, cadmium. These all would be present. Okay. Nowadays, research is progressing in this particular direction only. How to make high carbon steel having more malleability, ductility, and weldability. Research is progressing in this direction. Okay, a lot has been achieved. Now you can see a particular. example, if I give you, then Burj Khalifa is made from high carbon steel only. Okay, but it is very ductile in nature. It can undergo it is having a lot of strength. Okay, the structure can deform also under wind pressure. Okay, it can sway in both the directions up to certain degrees. I think 0.25 or zero point 0.5 degrees. Okay, it can sway. It can bear the resistance of the wind load also. Okay, that would be very large at such a height. Okay, and no structure is there in between to prevent the to obstruct the flow of wind. Okay, so those particular research has led us to this high carbon steel. Okay, which is having ductility also, which is having malleability also. Okay, so this is just for your information. Okay, yes, strength, high carbon steel would be extremely hard. It will be having high tensile strength, making it suitable for applications that require durability and wear resistance. It is less malleable, more brittle. Okay, compared to mild steel and low carbon steel. High carbon steel is less ductile, meaning it is prone to cracking under stress. Okay, yes. It is more difficult to weld due to its high carbon content, which can lead to cracking during cooling. This is important. Okay. Like other carbon steel, it has poor corrosion resistance. Where it is used to make the cutting tools. That was asked in this particular question. Okay. That was asked in this particular question. Okay. Springs, then high strength wires and knives. Why we use uh, high carbon steel for making the blades, for making the cutting tools? Because strength is very large there. Okay, it can undergo a lot of cyclic stress, loading and unloading, without any significant deformation. In your course on machine design, you would be taught what is cyclic loading. Okay, cycling loading, you have to when a machine is manufactured, then cyclic loading you have to assess for at least 1 lakh cycles. Okay, in case of tractors, you the components, okay, like brakes, like your indicator, like your switches, okay, these all are tested for cyclic loading and unloading for at least 1 lakh cycles. Okay, so wherever the stress condition is higher, okay, as well as cutting is required, there we often go for high carbon steel, because the hardness is very large in case of a high carbon steel. Okay, this is the thing. Here I have summarized the carbon content because it is very important. It is asked in a lot of places. Okay, that is why I have summarized what is the carbon content in different types of steels. Low carbon steel or mild steel would be having carbon content 0.5% to 0.25%. Then medium carbon steel 0.25% to 0.6%. High carbon steel 0.6% to 1%. Then ultra high carbon steel having very, very uh, sh- sharp edges. Okay, where hardness requirement is very large. Okay, where ultra high carbon steel is used. The percentage of carbon influences the hardness, strength, ductility, and weldability of the steel. Okay. So regarding this question, material of construction for furrow openers of a seed drill. Okay. The stress condition would be very large. Hardness is required. That is why we go for high carbon steel. Okay. One very particular interesting thing I'll just like to tell you. Okay. See, here furrow opener is mentioned. Okay, in case of cutting tools also. Okay, we can go for this type of structure also. Okay, in case of cutting tools. Okay, here from this place we can go for high carbon steel. Okay, high carbon steel, and the edge we can make from ultra high carbon steel. Ultra high carbon steel. In case of cutting tool. Okay, this particular methodology is just getting used nowadays in high end applications. Okay, it is very common to use this particular configuration nowadays. Okay, so this is very important. Okay, yes, this one is the explanation. The material of construction for furrow openers of a seed drill is typically high carbon steel. Okay, mild steel. While mild steel is easy to work and relatively inexpensive, it lacks hardness and wear resistance required for furrow openers, which must withstand significant abrasion and impact in the soil. Okay, soil abrasion would be there. Okay, soil abrasion would be there. Yes, soil abrasion would be there. Okay, and impact on the soil would be there. Yes, for you, I'll just repeat. Okay, whatever I told in previous 1 minute. Yes, I was telling you this particular information regarding the latest technology which has come into picture regarding the cutting tool manufacturing. Okay, so nowadays what is being done here, the end which has to be gripped, the cutting tool would be in this particular shape. Okay, so the end which has to be gripped, that is made from high carbon steel, while the edge which will uh, perform the cutting, that would be made from ultra high carbon steel, and these two would be fused at molten stage. Okay, so that we can just uh, extract, or we can just use we can just exploit the properties of both type of steels for our own benefit. Okay, so this type of particular concept has come recently into the picture. Okay, for shovel designing. Okay, for furrow opener designing, this particular concept has recently come into picture. Okay, as well as in case of disc manufacturing, in case of a disc plow. Okay, this particular concept has recently come into the picture. Okay, at the end, for enhancing the hardness, we go for ultra high carbon steel. Okay, as while in case of our middle part, where we have to just join the disk with the standard. Okay, at that place we go for high carbon steel, and these two are fused at molten stage. Okay, this is the thing. Yes, high carbon steel, that would be the answer to this question. Mild steel, while mild steel is easy to work and relatively inexpensive, it lacks the hardness and wear resistance required for furrow openers, which must withstand significant abrasion and impact in the soil. Okay. Significant abrasion would be there, impact would be there. That is why we go for mild steel. Okay. Yes, high carbon steel would be there, then carbon steel would be there, then high carbon steel would be there, and excellent hardness, strength, wear resistance, everything would be provided in case of high carbon steel. That is why our answer would be high carbon steel. Okay. Any doubts regarding this particular question, or we can move forward?
Yeah, we can move
Yeah, we can
forward.
move forward. Okay. Okay. Yes. Please do try to solve this particular question. Okay. It's a very important question regarding seed drill. Okay, it was there. I think some clue you must have got in the first question. Typical analogy is there, but this is somewhat different. Okay, so this is very common in the examination. Seed cum fertilizer operator, seed cum fertilizer drill will be operated using 35 bhp tractor. Speed is 4.5 kilometers per hour. Theoretical draft is 25 kg, and you have to calculate the number of times fitted in the seed, and you have to also take factor of safety, that is 2 into the picture. I'll tell you the methodology in brief. Okay, using the power of the tractor. Okay, you just try to calculate drawbar power of the tractor. That would be 2/3 of the power which is given. Okay, in this case I am just giving you the information. Okay, drawbar power, you have to take 60%. Okay, dbhp would be 60% of the brake horsepower of the tractor. That you have to just see here. Okay, you can just take it. Then from the drawbar power, okay, see here speed is there, okay, then soil resistance is there, okay, yes, theoretical draft is there, okay. So what would be the maximum draft which the tractor can pull, that you try to calculate, and then you divide it by the number by the draft which is experienced by the single tine. That will give you the number of tines fitted in the seed drill. Okay, try to calculate. If you are having any difficulty, then please do tell me. I will tell you the explanation. But first of all, try. After this step, as you know, P equal to F into V. So draft maximum which can be endured by my tractor, that I can calculate P by V. So that you try to just calculate. Okay. And after that, what is the D max and what is the D of a single time? You divided both the same. Okay. Keeping FOFs in the mind. Okay. In case you have to multiply it by 2. So theoretical draft experienced by each furrow opener for you would be 50 kg. 25 into 2. Okay. Just try to divide D max by D, then you will get the number of times. Okay. I'll give you enough time, 5 minutes for this question. Then at the end, I'll try to give the explanation. 34.2, I think approx 35. Okay. Very good. Yes. Correct option would be 26. Okay. I think that you must have just gone through some calculation mistake. Okay. You must have committed some calculation mistake. That is why I'll tell you the explanation in great detail. I've solved here the entire question. See here, 35 bhp is there, then 4.5 kmph is there, then 25 kg is the draft of furrow opener. Okay, I have calculated. I once I have designed, I have made the slides, but I'll calculate with you only. Okay, so at each and every step, I'll verify also whether I have calculated correctly or not. Okay, if some calculation mistake is there from my side, I'll also correct. Okay, so I told you drawer power is 60%. Okay, so 35 multiplied by zero point 0.6, that would be 21. Okay, 21 is the bhp and 1 hp is 0.746 kilowatt, as you already know. So multiplying by 0.746 gives me 15.666, that is 15.67. Okay, this is the drawer power generated by the tractor. Okay, then I told you P equal to F into V. So the maximum draft which can be done, just generated by the tractor, okay, that would be given by 15.67 is the kilowatt. Okay, 15.67 multiplied by 1000, that would be equal to D max multiplied by 4.5 multiplied by 5 by 18. Okay, so I'll just try to calculate here. Okay, 4.5 into 5 divided by 18. With you only I am calculating. Okay, so here I am getting uh, some another value. I'll just see. Okay, 15.67 into 1000 divided by 4.5 divided by 1000 by 3600. 1000 by 3600. Just a second. Yes, I'll be getting this particular value 12536 newtons. Your calculation is right. I have done some mistake. Okay. Yes, no problem. I'm still calculating each and every value. Okay, so that no confusion is there. So first I calculated DBHP 15.67 kilowatts. Okay, then I calculated Dmax. Okay, then Dmax, what I got, 12536 Newton. Okay, so it is in Newton, and I have been given the draft of time, my time in kg. So either I convert that into Newton or I convert this particular Dmax into Newton. Okay, so 12536 exact value I've got. Okay, so I'll just divide it by 9.81. Okay, so that, as you already know, 1 kg is 9.81 Newton. So it will come around 1277.879. Okay, that's value I am getting here. You can just see. One two se- Okay, you will be seeing things in reverse. No problem. I'll just tell you 1278 kg round off. Okay, 1277.879, 1278. Okay, and I already told you that FOS, factor of safety, we have to just keep in our mind. So it would be 50 kg. The draft which will be coming on a time is 25 kg, but since factor of safety is 2, so I'll multiply my draft coming on the time by 2, so my draft would be 50 kg. Okay, so dividing this particular value by 50 kg, I'll get 25.5575. That is the exact number of times which I am getting. So I have kept my factor of safety in mind. That is why I will go for number of times as 26. Had I been not using my factor of safety, then I would have reduced the number of times. I would have gone for 24 to 22 also, or 23 also. Okay. But since I am using the factor of safety, that is by a large margin, I have just multiplied, that is 2. Okay, so I'll go for 26. Okay, I hope it is clear. Calculated with you only also. Okay, yes. Can we move forward to the next question?
Yeah, we can move on.
Okay. As per the BI standards, again that particular standard only. Okay, six. No, no, no. Another standard. Year has changed. 6813 to 2000. The percentage of visible damage to the seats in a tractor operated seat rail should not exceed by 0.5%, 1%, 5%, or 2.5%. Okay. Direct question from the code. Okay. If you have any idea, then please do tell me. Okay. Rest I'll explain you the things in great detail. No problem. A, good, very good. This is the 100% correct. It is 0.5% only. Okay. See here. This particular is the code 6813 to 2000. Okay. This particular code is there. Okay. Second revision to that code 6813 to 1993. Second revision is there. Okay. Same code is there, but some values might have been revised, as well as some things might have been incorporated. Okay. See for yourself after the class. Okay. Scope is there, reference is there, then terminology is there, then animal drawn, tractor operated, both have been mentioned. Then size has been mentioned, what should have been the size, how it should be communicated. Like 9 furrow opener and 225 is the row spacing. Okay, then it has to be communicated as 9 into 225. And material of construction, great table is there. Okay, where I have to go for mild steel, then cast iron, the pneumatic tires have to be there. Okay, Then GI sheet should be used. Then seasoned wood, okay, plastic, fiberglass, reinforced plastic, PVC, aluminium, nylon. Okay, these is the material list. HDPVC, okay, high density polyvinyl chloride. Okay, it is mentioned for feed cup, and for fertilizer plate. HDPVC can be used. Okay, this is a newer material in the market. Okay, cast iron you must be knowing. Okay, very shock absorbing, highly ductile. Okay, highly brittle, not ductile. It is brittle in nature. Yes. Then mild steel is there. Then seasoned wood is there. Gunmetal is there. Then fiberglass is there. Reinforced plastic is there. Okay. Cast aluminum is there. For different parts, different materials have been mentioned, as well as which is the standard which should be followed, which should be the grade which has to be followed. For carbon steel, C55MN75. Okay, this is the code which has to be used. Okay, carbon percentage, manganese percentage has been given, and from that only C55MN75 is written. Okay, yes, see here. Then hardness has been mentioned. Okay, Brinell hardness. This is the particular index which is used for measuring the hardness. Okay. Furrow openers and shovel of shovel and shoe type shall be hardened, having Brinell hardness between 350 and 3 and 450 HB. Okay. From within these two particular values, you have to keep the hardness. Okay. When tested according to IS 1500. Okay, then this type for opener shall be specified in 5. Then construction requirements, what is the frame and toolbar, then wheels, then axle, then shaft, then seed and fertilizer boxes, then tines. Okay, everything has been mentioned here in the second revision of the code. Okay, and then see here, seed and fertilizer provision should be there, then seed and fertilizer tubes should be there, metering mechanisms, okay, then tolerances, then transmission system, then performance requirements. Okay, here each and every point is very important from an engineer point of view. Okay, either you would be designing a system, so for design you have to read the code, as well as you have to keep the entire thing in mind, as well as another job would be to evaluate the performance of the machine which you have to design. That is mostly done by engineers, because in companies already the detailed drawings are there. Okay, and detailed designing of the machine is there. Okay, then mass manufacturing is happening for machines. Okay, they go for mass manufacturing of machines. Then as an engineer, our job is to evaluate the performance, to evaluate the tolerances, to evaluate what the machine has been mentioned. Okay, what machine has been manufactured, and what is the quality of that particular machine, what is the performance of that particular machine. Okay, as an engineer, our job is mostly restricted to this only. Okay, I am telling you in general. Okay, if you are going for R&D, okay, both jobs you can have, but in general our job is to evaluate the performance. Okay, that is why it is very important from our point of view. Okay, yes, variation in dropping of seed and fertilizer in different feeding outlets shall not be more than 7 and 12.5% respectively from an average quantity obtained. Okay, it has been mentioned first requirement. Then variation in quantity dropped per hectare in quantity specified to be dropped at a particular setting shall not be more than 7 and 12.5% for seed and fertilizer respectively. Then the seed and fertilizer rate shall be easily adjustable up to 125 kg and 1000 kg per hectare respectively. This question was asked in previous session. Okay, so this particular uh, just aspect of the code is very important from examination point of view also, and from our engineering point of view also. Okay, the percentage of visible damage to the seed drill shall not exceed 0.5%. That was asked in this question. Okay, various percentages were mentioned, and the correct option was 0.5%. Then variation in dropping due to box filling at 1 by 4, 1 by 2, and 3/4 of rated capacity shall not exceed 10%. Okay. Yes. Then variation in quantity of seed dropping due to change in speed of the drill shall not exceed 15% of the quantity dropped under the specified speed. Then the variation in quantity of seed per meter of row length shall not exceed by 10%. The drill shall be able to sow seed up to 100 deep and should be able to draw fertilizer at a minimum of 25 to the side of the seed. Okay. Fertilizer placement is always done in side of the seed in case of a seed and fertilizer drill. Okay. Why? Because the roots of the seed emerge laterally. If the seed and fertilizer are dropped at the same place, the embryo is at a very natal stage. It might die immediately after emerging from the heat which the urea or any fertilizer emits when it comes in contact with moisture. Okay, that is why always in case of a seed cum fertilizer drill, uh, the fertilizer is placed at a distance which is laterally from the seed so that the roots emerge laterally. They can absorb the fertilizer, they can absorb the nutrients from the fertilizer and they don't get damaged. Okay, this is the reason. The draft of the animal drones drill shall not be more than 125 kg force. Okay. The wheel slip at a specified speed shall not be exceeding by 15%, and the drill shall be able to sow wheat and one or more of the following seeds: barley, paddy, millet, pea, Bengal gram, soybean, and pigeon pea. Drill shall be able to sow all type of granular fertilizers. Okay, this is the requirement. And the above requirements shall be tested in accordance to different test codes are there. Okay, so you have to keep those test codes also in mind while testing your seed cum fertilizer drill. Okay, this is the thing here. In brief, I am telling you about all the aspects. Then other requirements are also there. Have a look at them after the class. Okay. Then workmanship, then sampling and testing, then marking, packaging, BIS certification, marking, then packaging. Everything is covered here. Okay. So as a design engineer, if you get a job uh, at any company, okay, please do keep these test codes in mind for designing. Okay, as well as testing the any farm machinery equipment. Okay, as per the BIS standard 6813 to 2000, percentage of visible damage to the seeds in a tractor operated seed drill should not exceed by 0.5%. Okay, this is important. Reason already explained. Okay, any doubts? Then please do ask me. Rest, tell me. I'll move forward. Okay, we shall move forward. See here, another numerical question is there. A tractor operated seed drill fitted with sweep tie furrow opener is working at a speed of 4 kilometers per hour. Depth of furrow is 60 millimeters. Thickness of tine is 45 millimeters. Then the spacing between the furrow openers is given by 210 mm, 180 mm, 200 mm, 190 mm. In the design, this particular thing is taught at the very first stage. Okay, design of furrow opener. Okay, try to solve. Then I'll explain you with the help of a diagram what shall be the approach. Okay, already it has been covered in the lecture. Okay, but do try to solve, no problem. 210 mm. Very good. Very nice. Yes, the correct option is 210 mm only. Okay. How to solve this? We'll just see. Okay. See here, two different furrow openers are there. Okay. And it has been mentioned in the question that depth of furrow is 60 mm. This means this particular depth, which is marked by A, is 60 mm or 6 centimeter. First dimension. Okay. Then angle, which is angle of furrow, that has been mentioned as 45 degree. Okay. This means this particular angle, which is shown here as delta. Okay. I think it is not clear to you. I will clear it. Okay. This particular angle is given by, oh, just a second. I'll use this particular ink. Yes. This particular angle is given by delta. Okay. Angle of the furrow, that has been given as 45 degree. Okay. Another thing is spacing. Another thing is speed. Speed has been given 4 km/h. Okay. No use. Then depth is given. Then thickness of time. This particular value B naught, that is given as 45 millimeters. Okay. Yes. And distance between the furrow delta t has been given as 45 millimeters again. Okay. Delta t, distance between two furrows. Okay. That has been given as 45 millimeters. That would be equal to 4.5 centimeter. Okay. B naught was also uh, 45 millimeters, 4.5 centimeters. And A is the depth. Okay. That has been given as 6 centimeters. So every value I have written here, just taking from the question only. In my second line, first I have drawn my figure, then I uh, wrote the values. Okay. What has been given. Okay. Yes. Then spacing between the furrows. Okay, that would be given by, see here, spacing would between the furrow would be T naught. Okay, clearly it has been marked in the figure. Okay, and that would be equal to this particular dimension. Uh, just a second. Yeah, yes, this particular dimension. Okay, plus this particular dimension plus this particular dimension. Okay, these three dimensions I have to add in order to calculate T naught. Okay. So using my geometry, A I have been given. So if I take this particular distance as x, okay, from this point to this point, then I'll write here x upon A will be equal to tan delta. So x would be equal to A tan delta. Okay. So T naught would be equal to, first thing is from this distance, this particular small one, okay, which is emerging from thickness of the furrow, that would be equal to B naught over 2 plus, I'll take x, that would be equal to A tan delta, okay, plus delta t, distance between the furrows, plus again A tan delta, plus B naught by 2. Okay, that would be my T naught. Okay. So finally, what I'll get, T naught as B naught by 2, B naught by 2, B naught, okay, plus 2A tan delta T, 2A tan delta plus delta T. That would be my final line. Okay, final option. Okay. So here from this particular figure, I have calculated T naught as B naught plus 2A tan delta plus delta T. Keeping all the values which have been provided in the question, I'll just calculate 2, 8 tan delta t, A is 6, and tan delta 1045, okay, plus B naught by 2 plus B naught by 2, 4.5, entire thing plus 4.5, okay, 21 centimeters. See here, I have got 21 centimeters, okay, or 210 millimeters. That is the correct option. Okay. So if in the examination you encounter such a question, please do attempt it. Okay, and try to solve it. Rest will move forward. I think no doubt in this particular question. Okay. If you have any doubt at any point of time, please do tell me. Okay. The seed uniformity test for metering device is conducted by calibration method, hit and try method, sandbed method, none of the above. I already explained you in my first question. Please do attempt it correctly. Okay. Recall my first question. In that question, I told you about two methods. And this particular question, one method has been mentioned that would be the correct option. Okay. Sandbed method. Yes, very good. Sandbed method and sticky belt method are the two methods which are used for seed uniformity testing. Okay. See here, same code I have picked up from the very first question. Okay. Both the methods have been mentioned for measuring the seed uniformity. Yes, I'll just zoom in for you. Okay. Sticky belt method is there. Already I have explained you. Another method is sandbed method. If the provision of a sticky belt along with the conveyor is not there, as well as the provision for keeping these speeds equal is not there, then we go for sandbed method. Okay. So this particular would be the correct option. Already I have explained you. Okay, I'm not repeating. We'll just move forward to the next question. Okay. Various options were there. Calibration method. Okay, that involves adjusting the metering device. Okay, that is another thing, involves the adjusting the metering device. Okay, I told you in my previous lectures also, every metering device has to be calibrated before it can be tested. Okay, so it dispenses the correct seeds at the correct rate, important for setting up the device. It does not specifically test the uniformity of seed spacing. Okay, do remember. Hit and try method, that is not a valid method. Okay, it is used by students in the examination when they don't know anything. They just try to go for hit and try. Okay. Okay, hit and trial method is used in mathematics. Okay, sometimes when we don't know the exact solution, then we try a particular value, then go for it, check the answer which we are getting, then we have to know what is the correct value, then we calculate the error, then from that we go for another iteration. So in iterative optimization techniques in mathematics, hit and trial method is used. Okay, will be taught, you must have been taught this, and I think engineering mathematics too. Okay, Simpson's rule, trapezoidal rule. Okay, there the values are provided, but in case of these particular aspects, okay, optimization methods, this particular method is used, hit and trial method. Yes, then the correct option would be sandbed method. Okay, yes, this method involves placing seeds in a controlled environment like in a sand bed to simulate field conditions. It allows for accurate measurement of seed placement uniformity, making it most suitable for testing seed metering devices. Okay, so this particular option would be correct in this question. Okay, rest I think everything should have been clear. Any doubts anywhere, please do ask me. Rest we'll move forward. Yes. As per the BIA standard, variation in the quantity of fertilizer dropped per hectare and quantity specified to be dropped at a particular setting in a seed cum fertilizer drill shall not be more than 7%, 12.5%, 10%, and 15%. Okay. Already I told you. Okay. If you remember it, please do tell me. Okay. In this session only I told you. But do remember it is fertilizer. Okay. Don't get confused it with seed. Okay. Yes. Any idea? If you remember it, you have gone through the code. B. Very good. Very nice. It is, I think, correct. 12.5% only. Okay. See here, this code I already explained you in my previous question. Okay. 6813 to 2000. We have covered the scope, references, terminology, types, size, materials, everything we have covered. Okay. Then construction requirements. Okay. Yes. Then seed and fertilizer attributes, then metering mechanism, then transmission system, then performance requirements. I already told you about each and every point. Okay. So in that thing, I already told you that the variation in quantity dropped per hectare and quantity specified to be dropped at a particular setting shall not be more than 7 and 12.5% of seed and fertilizer respectively. Okay, so the correct option would be 12.5% for this question. Okay, I hope this is clear. Okay, let's move forward. Yes, this particular question is very interesting. Which of the following forces need to be considered while designing the toolbar or frame of a seed drill? Torsion, bending, torsion and bending, then twisting, torsion and bending. Okay. Yes, please do answer it. Okay. Toolbar of a frame. Okay. Which forces would be acting? Just consider a toolbar. It is attached with a furrow opener. Which forces will you go for it? Yes, two people have answered. B and C, bending force and torsion and bending force. The correct option would be torsion and bending force. C. Okay. See here, torsion would be acting. Why torsion is acting? Because see here, I'll just draw. Okay, no space is there. Just a second. This particular bar is there. Okay, I am drawing the front view. Okay, attached to it, there is a furrow opener. Okay, attached to this is a furrow opener. So from the main frame, okay, draft would be acting at this particular point in both the cases, and that will be transmitted to the mainframe. Okay, why bending force is coming into the picture? Okay, because that load will try to create a torsion at this particular place which I have encircled. Okay, it will try to create a torsion in the opposite direction, which will further try to bend the shank. Okay, this particular thing that is known as shank of the cutting tool. Okay, of the cultivator or any tool. So it will try to create a torsion at this particular encircled place. Okay, as well as it will try to bend this shank. Okay, because loading is there. Okay, the cultivator, it would be having some self weight also. Okay, so due to self weight, it will have a bending tendency at the frame. Okay, this particular frame. Okay, and due to draft coming from the uh, soil, from the interaction of the cutting tool and the soil. Okay, there would be torsion also created. Okay, hence, torsion and bending force would be the correct option. No twisting is happening. Okay. Where twisting is happening, like if you take a rope and try to twist it, okay, you try to apply a couple at both the ends, then at that case, we consider it twisting. Okay. Like you twist something. Okay. Like you twist this pen, apply force at one end in one direction, another end in another direction, then in that case, it would be twisting force. Okay. So in this particular design of the toolbar or of a frame of a seed drill, okay, this particular vertical one is toolbar. Okay, toolbar. Sorry for my bad handwriting. And this particular one is frame, main frame. Okay. So at both the places at the mainframe, bending force would be acting at the toolbar. Ultimately, it will create a torsion which will be transmitted to mainframe only. Okay, so we have to see ourselves. We have to design our seed drill. Okay, in keeping in mind both the forces. Okay, torsion as well as the bending force. Okay. Yes. Yes. See the explanation also I have provided you. Seeder encounters even terrain obstacle the toolbar can twist. Okay. The twisting force needs to not twisting, torsion. Okay. Torsion is something else. Okay. Twisting is something else. Here, twisting is not an appropriate term. It would be torsion. The torsion force. Okay. I'll just write it torsion here. Torsion force needs to be considered to ensure the toolbar has enough strength to resist the deformation. Then another thing was bending force. The weight of the seed hoppers, then seed metering mechanism and seeding all exerts a downward force. Okay, that will try to bend the to, frame. Okay, it should be able to resist that without sagging. Sagging is this particular thing. Okay, this is a straight frame. Okay, when it will undergo sagging, it the structure will deform to somewhat this shape. Okay, this is known as sagging. Okay, both torsion and bending force act on the toolbar. Option would be C. No twisting is happening. Okay, no, only torsion and only bending would not be there. Both would be there. Okay, yes. Any doubts, or we can move forward? Anything, any explanation is required, please do tell me. Rest we can move forward.
No, we can move on to next question.
Okay, okay. Okay, we shall move forward. Okay. The draft of an animal drawn seed drill should not be more than 125 kg, 175 kgf, then 165 kgf, then 155 kgf. Okay. If you have just seen it, okay. Recently, I told you, yes, yes, very good. A only, yes, yes, very correct. It is A only. Okay. It is directly from the code. That code only I'll refer. Okay. 68132 2000. And in the ninth point, it has been mentioned the draft of the animal drawn drill shall not be more than 125 kgf. Okay. Yes. Why is it so? I'll just tell you in brief. Okay. One oxen or one ox. Okay. Oxen is plural. One ox can generate force of 100 kgf. So two a pair of ox or a pair of oxen, they can generate a total draft of 200 kgf. Okay, but it's an animal. Okay, it is performing task for us. Okay, so we try to reduce the amount of draft totally. In case of animal drawn equipment, we design the equipment in such a manner that the comfort of the animal also comes into the picture. Okay, we have to keep in mind that the animal should be comfortable, okay, while the operation is happening. It shall not be like that animal is fully exhausted after the operation. It will just die or it will resist the our operation. Okay, so the total draft shall be kept less. Okay, in case of animal operated plow also, animal operated seed drill also, or any equipment, try to design. Okay, designing is in your hands. Make some chain, gear, sprocket. Okay, these type of arrangements, try to think yourself. Okay, in such a manner, place some bearings. Okay, so transmission torque you can reduce, and similarly you can just if you reduce the cross sectional of the toolbar, okay, then your total draft requirement will decrease. Okay, so try to design the animal drawn equipment in such a manner that the total draft, okay, it is much less than 200 kgf. It is the maximum which a pair of oxen can generate. Okay, 200 kgf. Okay, this is the thing. Typical pair of oxen can comfortably handle between 150 to 200 kgf, but we'll just try to reduce it as low as possible. Our work shall be completed, no problem, but at the same time, the oxen should not get exhausted. Okay, yes, 125 kgf would be a reasonable target. That is why this has been kept in the code. Okay, yes. Last question for the day. That is also from code. Okay, 2 3 numericals were there. Now the last question is also from the code. Yes, the size of the trial plots as per the BIS recommendation for animal drawn drills should be at least 0.2 hectare, 0.1 hectare, 1.2 hectares, and 1.5 hectares. Yes, Pradeep has answered it. Point two. Okay. Point one. Okay. Now yes, yes, no problem. I can expect that some confusion might be there. Yes. Point one hectare. Yes. Any other answer? Yes. Yes, yes, yes. B, you are thinking. You are absolutely correct. It is zero point 0.1 hectare only. Okay. Yes. See here, same code 631629993. It has been given very clearly in this particular code. I'll zoom in for you. Okay. Operate the drill in a well prepared seed bed that is at least 15 centimeter deep, firm, fine structure, smooth and level, relatively free of surface stress, and at good moisture content. The size of the trial plot shall not be less than zero point 0.1 hectare and zero point 0.2 hectare for animal drawn and tractor operated drills respectively. Okay. So in this particular case, I think animal drawn drill was being asked. Okay. So the correct option would be this one, 0.1 hectare. Okay. Yes. So these were the 10 questions from my side. Okay. Okay. This is the end of the session from my side. Okay. If you are having any doubts, then please do ask me. Rest, you can kindly leave the session. Okay. Please do join the session next week at the same time. Okay. Next week, Saturday at 3 p.m. Okay. Yes. If you are having any doubt, then please do ask me. Okay. Session is open to you people. Okay. Yes. Okay. I think you are providing the option to the last question. Okay. No problem. I already gave the explanation. Okay. It would be B, zero point 0.1 hectare. Okay. Let's It has been clearly mentioned in the code here. Okay. zero point 0.2 hectares for tractor operated drill and zero point 0.1 hectare for animal drawn drill. Okay. No doubts. Thank you for today's session. Bye, sir. Okay. Thank you so much for joining the session. I hope that it is fruitful for you. Thank you so much. Please do join the session same time next week also. Okay. Clarify all your doubts. Thank you so much for joining the session. Yes, Abhishek ji, please do ask me. Okay, okay. Yes, take your time. I'm here for 5 more minutes. No problem. Coefficient of filling flutes in a fluted roller mechanism. How much? Okay, good. Yes, that has also been mentioned in the codes. I think what shall be the coefficient of filling? Okay, see here, filling index is there. I think that has been covered in the theory. Okay, so right now exact value I'm not remembering, but that coefficient, what does it indicate? That what number of flutes, okay, what number of orifice, okay, in the shape of u, okay, undercut u, how much they should be filled. Okay, so coefficient of filling of flutes for easy flow, I think that we generally keep between zero point 0.5 to zero point 0.6. Okay,
Okay.
the next class I'll just go through the codes. Okay, go through the theory and I'll tell you the exact value. Okay,
Okay.
but I can tell you the logic. Okay, that is generally kept somewhat between zero point 0.5 to zero point 0.6, zero point 0.8. Why is it kept? So that the flow of the seeds, okay,
Mm.
it can happen without any obstruction. The multiple flow is just restricted. Okay, multiple flow meaning at the place. Okay, the plate would be rotating. So in the orifice, if two seeds fall, okay, that would be somewhat wastage of seed. Okay, so for that purposes only, it is always kept in the ranges zero point 0.5 to zero point 0.8. The exact value I'll tell you in the next class. Please do remind me. I'll go through the code and then I'll be able to tell you the exact value for which type of orifice, what would be the coefficient of filling of fluid, how much it would be kept. Okay.
Okay, sir. Thank you, sir.
Okay. Any more doubts? Please, my sincere request is be regular. Okay. Please do join the session in the starting. Okay, not in the middle. Okay. Yes. In the previous session, week 4 was much of a use. Okay. Please do revisit it from the recording. Okay. There I've just explained multiple concepts which are very useful in our farm machinery. Okay. In this particular domain, that is why I'm emphasizing on week 4. Okay. Week 5, the questions were directly from the code. Okay. You can do them without my help also, but week 4 content, please do revise. Okay. My sincere advice. And please, my sincere advice once again for you is do join the session in the starting, not in the middle. Okay. Yes. Okay. Any more doubts, then please do ask me. Rest you can do join the session next week. Okay. Okay. Thank you so much. Okay. Okay. I'll end the session. Okay. Thank you so much for joining. Please do join the session next week. Okay. Thank you so much.